Today we're going to talk about a special type of series. It is called a p-series. And in order to figure out the rules for the p-series, we're going to use the integral test to help us figure out the rule. So a p-series is anything, a series that is anything in this form 1 over n to the p. And we're going to use the integral test to figure out for what values of p that this series is going to converge or diverge. So let's assume that we have a series 1 over n. And I want to figure out whether it converges from 1 to infinity. So I'm going to use the integral test here. So I'm going to rewrite this. So using the integral test, I'm going to integrate this function. So 1 to infinity of 1 over x dx. I'm going to rewrite it with the limit statement. This integral is natural log of x. I know right away, as soon as I plug in infinity for t, this is going to become infinity. So I can clearly say that this diverges. So anytime you get to a p-series that looks like this, you can just say that this diverges because you recognize it is a p-series, and you're done. You do not have to show any work. Now, the conclusion would be the same if I made this number on the top a 2. It doesn't change if the number on the top is a different value. That is just your constant multiple. Now let's think about what happens if you have a p-series. So again, something in this form. But let's say this p-value is not 1. Let's say it is greater than 1. So again, let's try to go ahead and do the integral test and see what happens. I'm going to rewrite this as an integral. 1 over x to the p of dx. So again, I am assuming that the p-value is greater than 1. I'm going to go ahead and rewrite this by bringing the exponent to the top. And really, to integrate this, we just have to use the power rule. So rewrite with the limit statement. If I add 1, I'm going to divide by the power. Okay. And I'm going to go ahead and plug in my t for x, t to the negative p plus 1 over negative p plus 1 minus, plug in the 1 for x, I get 1 to the negative p plus 1 over negative p plus 1. Okay, let's think about what's going to happen to this fraction right here. Okay, the second fraction, if p is some number greater than 1, this second fraction will always be a number, and it doesn't matter what that number is. Now this particular fraction right here, if p is a number bigger than 1, notice what happens. So for example, let's pick 3 for p. If p is a number bigger than 1, notice that this exponent is going to become negative, so the t ends up going to the bottom. So when you plug in infinity, that infinity ends up being on the bottom of the fraction, so this fraction really goes to 0. So you have 0 minus some number is going to be a number, so this p-series converges. So anytime you have a p-series in this form, and that p-value is bigger than 1, you can say it converges because you recognize it's a p-series. So if you are given this particular problem, 1 over n cubed, you just tell me it's a p-series and it's bigger than 1, so you can say right away that it converges. If you don't remember this, you can go through and do the integral test. Now let's see what happens if that p-value is less than 1. Okay? I'm going to look at this entire piece again because we don't need to reintegrate this. But this time, if this p-value is less than 1, so let's think about it. If p is 1/2, well, you end up with negative 1/2 plus 1. The t will still end up on the top because this exponent will be positive. So that means when you plug in infinity, infinity is going to be on the top. So you end up with infinity minus some number, which is going to diverge. So in this scenario, if you end up with a p-series that is less than 1, you can always say it diverges. So for example, if you end up with this, 1 over n to the 1/2, so that p-value is less than 1, you can tell me it is a p-series, and you recognize it diverges, and you are done. So p-series are nice because as soon as you see it, you can tell me whether it diverges or converges. So let's look at 2 examples using what we've learned. So when I look at this series, I notice it is a p series. The p-value is 1, which tells me that it diverges. That's all you need to tell me, and you're done. This one is also a p series. I notice the p-value is 2, which tells me that it converges. That's it.